Today, we're going to be taking a look at how to create a component library for React. Before I get into what a component library is, if you already know what it is and want to get straight to the code, then you could skip through these sections in the chapters below. If you want a little more clarification, then stick around. So basically, it's a reusable set of components that you can use in your React project over and over again, and you can use them across projects. So if you've ever used something like React Bootstrap, React or Material UI, then you've used a component library and you know how to use everything inside of it. But you'll also know that one of the advantages of using these libraries is that all of the components are always ready for you and you're not rewriting the same code over and over again. So a component library can include things like custom React JSX elements, components, React hooks, class components, common functions, interfaces, module, utilities, basically anything that you can use inside more than one project. There are two distinct advantages to using a component library, and that's efficiency and consistency. So reusing components is much faster than creating them over and over again, but it's also really good if you have a big development team or even more than one person working on a project. That way you can make sure all of your code stays consistent if you're using the same components over and over again. Being consistent ensures fluidity and that all of your components are going to follow the same general theme, assuming that you set your component up library like that. For example, in the one we're going to be looking at today, I'm going to create a button and it's just going to have a couple of overrides. But if that's how you styled or programmed all of your components, then you know what to expect every time you use something from your component library. That way you don't have to go around creating brand new code. It's already all there for you. So now that you have a basic understanding of what we're going to be doing today, let's go ahead and set up this project. Let's start off by going to the folder of your choice, opening a terminal and typing npm init. This is going to create a new package.json file, which is going to define our project. As you can see here, I'm just going to quickly go through everything and use the default names and options that it's giving me. I'm going to edit the package.json file thoroughly, and I'm going to be doing that right after this, so we don't really have to worry about any of these steps. So go ahead and open up this folder with your IDE of choice. I'm using Visual Studio Code, but you can use whatever you want. And open up the folder with the package.json file lies. So now that we have our package file open, I'm going to open up a terminal. And the first thing I'm going to do is install some dev dependencies. So the dev dependencies I'm going to be doing are @types node, @types react, @types react DOM, and then React, React DOM, and Typescript. These are all going to be dev dependencies because the component library is actually going to use the dependencies of your project instead of installing them a second time. So you're already going to have React and React DOM installed when you create your project. So you're not going to need to install any of these as a real dependency. Now, since these are all dev dependencies, we actually need to tell this package.json file that we want to use the user's existing React and React DOM. We don't want to install our own. So instead of making these dependencies, we're going to add a new section inside of our package.json file called peer dependencies. And basically what you're going to do is you're just going to go ahead and copy and paste the React and the React DOM from your dev dependencies because you want those versions to match exactly as they're installed. In order for this to work properly, please make sure your React and React DOM in both your dev dependencies and peer dependencies are the same version. So next, go ahead and add a description. You can just say something like, this is my component library. I'm just going to say this is an example, but you can put whatever you'd like. So for my main file, this is going to be pointing to a common JavaScript or a common JS module. So it's going to be in our dist folder /cjs/index.js. And when we create our TypeScript configuration, I'm going to explain why we're doing it this way. Next, we're going to add a key called module. And it's going to point to a dist/esm/index.js. So we're going to be compiling two versions of the code. Next, you're going to go ahead and add a files section. This is going to be a string array. It's going to have one string in it, and it's just going to be our dist folder. So in our script section, we're going to create our build command. We're going to have three commands. We're going to have our main build command, an ESM build, and a CJS build. So how we're going to define this is first, we're going to make our build key, and we're going to make two keys copy and pasted from it. One's going to be :ESM, one's going to be :CJS for common JavaScript. So in my build command, first I'm going to do an rm-rf, my dist folder. So if I have a dist folder, I just want to get rid of it and make a new build. Next, I'm going to leverage a NPM module called Prettier. I use this in a lot of my projects. This Prettier section you can leave out if you want, but I like to format my code. So install Prettier globally and you can follow along with me. I'm going to use a Prettier -- write and I'm going to target my source folder because that's where all my code's going to be. Next, I'm going to run npm build esm and I'm going to run npm build cjs. So this command, what it's going to do, it's going to format my code, delete the old distribution or delete the old build, and then it's going to create 2 new builds for me, one for each target of JavaScript code. Inside of the build ESM key, all I have to do is type tsc because we're going to configure our TypeScript file to take care of all this. But for the CJS, we have to do tsc -- module common js -- out directory and change this to dis/cjs because our TypeScript file will be pointing to the ESM folder. Again, I'll explain in the TypeScript file the difference between these two and why we're doing it. But basically the main difference between CJS and ESM in the terms of React is one allows you to compile this for common JavaScript, so people who are just writing their applications in vanilla JavaScript, and for people who are using TypeScript. So either or will work. Just because we created the component library with TypeScript doesn't mean that the user can't just use JavaScript. They don't have to use TypeScript. Next, I'm going to go ahead and add my author key, change the license to MIT because we like everything to be free. And that should be everything we need to do inside of our package.json file. So now if we were to build it, once we have some code, everything should work fine. Next, I'm going to open up my terminal and type tsc --init to initialize a TypeScript.json file and add TypeScript to our package. So now I'm going to create 3 settings files, a Prettier RC for my code formatting, my settings.json, and I'm going to edit my TS config. So let's go ahead and create these 3 files, and then we're going to go through them. Create the Prettier RC file, the .prettier RC file, in the main directory of your library. Create a new folder called .vscode and create a settings.json file in there. And now we have the 3 configuration files that we want to edit. So I'm going to copy and paste inside of my settings, and I'm going to go through the settings for you and what they all mean. So the important ones here are the default formatter is this esbenp.prettier_vscode. This means that I'm using my Prettier code formatter, and with the editor.format on save and format on paste set to true, every time I save or paste, it's going to automatically edit that file for me and format it. And you can see here I have a Prettier extension installed. There's a couple of them available, and I'm using the top one here that's written by the Prettier company. You can also see that I have like word wrap on and bracket colorization enabled. You can put any settings you want in here, but these are just some basic ones that I do. Next, the settings here that I have with my Prettier RC. This is just how I like to format my code. You can go ahead and go to the Prettier documentation, and you can fiddle around with this any way you like. But Prettier will use this file in the base of your project to decide how it's going to format for you. So this is how I like to do it. And finally, I've copy and pasted in here my tsconfig.json. So here I can go through and tell you what all of these mean and how it's going to compile. If you want to skip this step, if you don't really care, then go ahead to the next chapter where we get right into programming our custom components in our component library. So the allow synthetic default imports allows you to import files that have a bunch of exports as one variable instead of doing *as. For example, you might see import React from React instead of import *as React from React. As long as this is set to true, you can use either or. Declaration allows us to create our types files to go along with our compile.js. So this means that anybody using this component library, when they install it, they won't have to install an extra library for the types. The type definitions will be included automatically. The ES module interop just basically fixes some compiling issues that might happen depending on the different versions of React and ES5, ES6, etc. that you're compiling for. For a better understanding of this, I have a link in the description below. The JSX tag is just telling us to compile it for React. It's just telling us what we're going to do with our TSX files, and it's just going to turn them into JSX files for React. Nothing special here. Next, the lib array here, you will see that there's a bunch of things here, ES5, ES 2015, 16, DOM, ES Next. These are all the targeted libraries for where your functions will work, because some functions may not work in newer versions of JavaScript, even though they work in the old ones. So this will ensure compatibility across them. Most importantly, though, you're going to want to have that DOM in there because you do want window and document global definitions available because React has them as well. So you're going to want to make sure that you have that one in there. The types here is just telling us what we want to target our types for. Just having Node in here is sufficient. Having the module set for ES 2015 instead of the normal CommonJS helps our component library be compatible with React itself. The module resolution set to Node assists us with that as well. No implicit any means you have to always declare what a variable is. You can't, for example, have a function with a variable in it that doesn't have a type resolved to it. You always have to declare what it is, or actually declare any. You can't implicitly declare any. And the no unused locals just make sure that all of our variables are in use, or you're going to get a TypeScript error. Our out directory is set to dist/esm, so it's going to compile all of our React code there for us. And when we're using our CommonJS, we're just going to pass in the module as CommonJS so that it will change it to the CJS folder, so we have compatibility with both. That way, if somebody's not using TypeScript, they have the CJS. If they are, they'll have the ESM. Nice and simple. Having source map set to true helps debuggers and other tools display the original TypeScript code when actually working on the emitted JavaScript files. So that's pretty useful. Having strict set to true ensures the hardest possible linting where you can't have any mistakes, otherwise TypeScript is going to shoot a whole bunch of errors for you, and it might not let some things slide that it would in the past. And the target ES6 is the target module language that we want to deploy to. ES6 is generally used by all browsers, so it's a pretty safe bet just to use ES6 here. So now that we're finished our configuration, let's go ahead and create our source folder inside of our main directory. And inside of the source folder, let's go ahead and create an index.ts file. Then let's create a components folder. Inside of it, we're going to create a button.tsx file. And inside of here is where we're going to declare our custom component for our component library. So I'm going to go ahead and just use this autofill function component I have here. If you don't have any snippets enabled, I have a tutorial on how to create one, but if you do have some sort of React snippets installed, when I type FC here, it just creates a function component for me so I don't have to type it out. I'm going to go ahead and change this to button and get rid of the page. Inside of my return, I'm going to change the paragraph to a standard JSX button. Next, I'm going to pass in my props by doing a const children inside some brackets equals props, and then pass my children into the button. So all I'm going to be doing for this button is just adding some basic styling that I can override. So maybe you just want to have some quick options instead of always adding the style tag. So what I'm going to do is I'm going to copy and paste this react.detailed HTML props, this entire line set here from my button, and I'm going to extend my interface so that this button component that I'm creating inherits all of the things that come on a JSX button. Inside of my props, I'm just going to add two more things. I'm going to add a background color that's a string, and I'm going to add a color that's a string. I'm going to make them both optional. And inside of my function component, I'm going to pass them into my props definition right after my children declaration. And I'm also going to pass in the style. So how this is going to work is I'm going to make a copy of my style prop here, and I'm going to correspond it to my react.css properties type. I'm going to make this equal to style or an empty object. How this is going to work is if the style is defined, I want to alter the style that's already passed in. And if the style is not defined, I'm going to make a new React CSS properties with all of the default styling. Next, I'm going to override the defaults. And how I'm going to do that is I'm going to check to see if background color and color exist. And if they do, I'm going to change my underscore style prop to equal the one being passed in for both background color and color. Once I've done this, then I'm going to go ahead and go to my button, and I'm going to add a couple things here. First, I'm going to pass in my style equals underscore style so that my styles are applied. And then most importantly, I'm going to pass in my props with the spread operator. That way, if I want to use like the buttons on click or some sort of function that comes on the standard button, I'll have access to it now because my interface has been extended. So this is all I really need to do for this component. I'm not doing anything else. This is going to be just a simple example. The only thing I'm going to do is export const button. I'm not going to make a default export because I want to be able to export everything consistently. And I'm going to show you how to do that right now. Go ahead and create an index.ts file in your components folder. We're going to export star from // button. And then inside our index.ts file in our source folder, we're going to do the exact same thing, but for our components folder. That way, anytime we add components to our component library or folders, if you do it this way, it's very easy to export everything into the package. So I'm going to run my build command here, and you're going to see that the rm-rf dist and prettier right is running. You'll see that it went over my 3 components with prettier. It didn't change anything because they're already formatted with my VS Code settings. And then you'll see that the ESM build is running with TSC. And then you'll see that the CJS building is running with the module common.js and the different out directory. Now let's take a look inside the dist folder and open up these folders, and you can see that the index.js files were created, map files were created for them, the types files were created for them. Everything seems to have been compiled nicely. But in order to test this, we're going to want to actually install this library now into an existing project. So I'm going to be doing this locally. I'm not going to be doing this from NPM. In order to publish to NPM, I can create a different video for that if you like. But for now, we're just going to install this package locally. It should be noted that if you're using React hooks inside of your component library, they will not work locally because you'll be running 2 separate copies of React with your dev dependencies. So if you want to test your hooks, you're going to actually have to publish your package to NPM. So I'm going to go ahead and open up this basic app I have that I created with create React app and TypeScript. There's nothing special going on here. I'm just going to run npm start. And you're going to see that all that shows up is just this hello message. That's it. So I want to bring my button into here. So what I'm going to do is I'm going to run an npm install, and then I'm going to target the directory where I've created my component library where the build sits. So this on my computer is going to like an npm install, and I'm just going back one directory and selecting my component library example. You're going to see that it installs just like a normal npm package would. Once it's installed, I'm going to go ahead and try and import my button here. So I'm going to do an import, and I'm going to do from, and then my component library example. You can see it shows up. And since it's compiled with types, I don't have to install types for it. You can see that my iButton prop showed up because they're being exported, but I just want this button. So let's go ahead and insert the button here. And we're just going to insert a cool message here saying cool button. Let's run an npm start and see what happens. You're going to see that my cool button has showed up. Everything's working just fine. So let's go ahead and modify it a little bit. Let's add a color. Let's call it white. And let's add a background color and do black. So these should override the default stylings. If I hit save and I go back to my web page, you can see that my overriding worked perfectly. Lastly, let's go ahead and override some other styles to see that if overriding the colors and the styles work together. So I add some padding here, and that seems to work just fine. And then lastly, let's add an on click or an on press. And go ahead and just call up a little alert saying that your button was pressed or whatever message that you want. Let's save that. Go back to our project, and you can see that the button is working just fine. So there you have it. That's how you firstly create a component library, and then as long as it's local, you can go ahead and install it this way, but you can see that the component library is working just fine because the app that I'm using has React installed, so it doesn't need any of those extra dependencies. It just uses the node modules that you have for your already existing React project. Just make sure that the versions that you are using are compatible. So now that we've finished with the component library and we've shown how it works in practice, let's ask ourselves a couple questions here. When should I use a component library? I think there's a couple different answers to this question depending on who you are, but personally, I wouldn't use it if I'm just doing one project. I would just create my reusable components and keep them inside that project itself. But if I have a large project or several large scale projects going on at the same time, or I'm working with multiple developers, then I think it's kind of a no-brainer to go ahead and try and create a component library. That way you can have consistency across all the code as the code base grows. Is it useful for a small project? Again, yes, if you have multiple small projects, but if you only have one, I would probably keep everything in-house in that one project. If you have any questions, please comment below, and like and subscribe if you haven't already, or buy me a coffee if you're feeling generous. Other than that, thanks for tuning back in, and we'll see you in the next one.